Okay, so this is my demonstration for manipulator. So this is my front panel. It gives you two options: the speed where which it goes to, and the shelf it goes to, with 0 being where it would pick up the Festo puck. So if I just quickly demonstrate it, so it moves to 0, it moves to shelf 1, and then it can immediately after it can move to the next shelf, or it can go back and pick up the puck. I just wanted to demonstrate it can move to each shelf in series, but then if I want to specify 0, then it will come back down and pick up the puck. So then if it picks up the puck and then it wants to go to shelf 2, it can just move up, straight goes to shelf 2, it doesn't have to go to shelf 1. And if it wants to go to 0, again, to pick up a puck, then go to shelf 1, and then can go straight to shelf 3 without needing to go to shelf 2 or even picking up the puck again. I'll quickly show the code here. So the arm gets created here and then initialized with the parameters. When I initialized it, I scaled it up just because I believed it was a bit better. It was more clearer to see. These are some initial coordinates that I set to the robot, which is where it would be picking up the Festo puck. As in this task, it would be picking up a Festo puck and taking it to a shelf, so it just make more sense that it has to start to pick up a Festo puck rather than the Festo puck being the home position. I have that translated going into forward kinematics to get the correct pose, and then that goes into the selection of which area it wants to go to. So you can see there's two coordinates, as the first set gets it to the height, and then the second coordinate moves it into the shelf. So if it did have a Festo puck and it had to go to shelf 2 and then shelf 4, it won't immediately just move up. If the shelf's in the way, it would collide to the shelf. So I've set it so to be into like an empty space it would go into and then move in. And then they get put into an array and fed into the Cartesian trajectory. This is also where the intermediate points are specified, which just specifies how many points are generated for the trajectory. So of course, the less points, the faster it'll go; the more points, the slower it'll go. So I just have just a speeding number to show that, to allow you to see how quick. So for example, in an industrial setting, you'd probably have this go quite fast, but just for demonstration purposes, it's slower. Or if it were interacting with other people, it would also want to go slower. You can see that this is in a while loop, and also this one's in a while loop, as the Cartesian trajectory generates not just 2 points, it generates many points. So the loop is there, so it can put one coordinate in. Next loop sends the next set of coordinates, which we also have in this loop for it to execute it. I made this go to infinity because so this is the max steps. So the maximum number of steps it has to complete it in. I set it to infinity because it just gives it infinite time to calculate the task. Originally I had it set to this number, and I realised there's no point in having it. It's just this absurdly high number. I'll just have it in infinity. This is the mask set. So the mask basically lets the 3D picture have not the 3D picture, sorry, the inverse kinematics use these axis. So I've disabled the y-axis because from this view, it will. If I didn't have it disabled, it would move to crazy locations. So for also demonstration purposes, I have it set to that. So for example, if I change this, it would still work, but so if I initialize it to 0, it would just go wide off, as you can see there. So specifying to not use this one. So as we know, so like in my example, the shelves are directly next to the arm, so it doesn't need to move the Y a lot. But it can, but if I go back to it, you can see that I've allowed the theta Y to move, so it does have some movement, but it just doesn't, directly move the down the Y axis completely. Yeah, so